Hello guys, welcome to the DMS online school page with me, your teacher DMS. In today's lesson, I'll be looking at the grade 11 chemistry practical lesson on acids, bases, and the salts. Okay, so if you are new to this page, you are most welcome. And on this page, I teach mathematics, biology, physics, and also chemistry. All right, so in today's lesson, just as I stated, I'll be teaching you a grade 11 chemistry practical lessons on acids, bases, and the salts. And by the way, I offer online lessons in chemistry, mathematics, physics, biology. And if you're interested in online lessons, please click on the WhatsApp button below or contact me on the line that is appearing on the screen. All right, so in today's lesson, we'll be looking at a practical lesson just as I stated earlier on. All right, so without wasting much of your time, let's go straight into this lesson. Okay, today we'll be looking at a typical practical on the acids, bases, and the salts. So we'll be looking at a practical or a typical practical that can come on acids, bases, and salts. So it does not matter whichever place you are doing your tuitions from, or you'll be writing your GCE exams from, because me, as I teach online, I also teach practicals on those topics that require practicals. I do actual practicals that come on those particular topics. All right, like I'm teaching in this chemistry on acid, bases, and salts. I'm teaching a typical practical that comes on acids, bases, and the salts. So here we are going to look at a situation that we may provided with. Okay, so we are saying, suppose you are provided with three unknown sample solutions labeled A, B, and D, C as shown below. So you are provided with solution A, solution B, solution C, and then you are provided with a test tube in a test tube rank. Then you are provided with a dropper here. Then you are provided with a petri dish. On it there is a red litmus paper and also a blue litmus paper. Okay, I said this one is a dropper. Then these are solutions contained in conical flasks. So these are conical flasks. Then this one is a petri dish like this. Then I said, these are test tubes, written as that test tubes. Then this one is a test tube rank. Okay, then this one, I said this one is a red litmus paper, and this one is a blue litmus paper. Okay, now let's look at the typical procedure that you must undergo to answer this practical to do this practical lesson in chemistry. Okay, so part A here says, using the litmus papers provided, carry out some tests to identify the types of unknown solution provided. Okay, now you are provided with the litmus paper, then you need to carry out some tests to identify the types of unknown solutions provided. Okay, so you may have a procedure like this, so which says, number one, put little amount of solution A to a test tube and dip red and blue litmus papers and make observations. Okay, so procedure number one says, put little amount of solution A to a test tube and dip red and blue litmus papers and make observations. Okay, so we'll get this is the solution A and then a test tube. Then we'll get some few drops using a dropper, some few drops. So you press a dropper, you press it, and then it should suck. You press it and release so that it sucks solution A. Then you push the solution A so that it goes into the test tube. Okay, then after that you are going to dip red litmus paper. So you pick a red litmus paper here, then dip it there. After you dip, you make careful observation. Okay, what have we seen? So write observation. You write what you have seen. Okay, so here we have seen that the color of red litmus paper changes to blue after dipping it in a solution A. Okay, this is what we have seen. Before we dipped it, it was red. Now after dipping it, it changed to blue. Okay, then next we are going also to dip blue litmus paper also in the same solution A, which has been put in test tube. Okay, so get blue litmus paper, we dip it there and also make careful observation. So we'll make observation 2 here, which says Nothing we have seen, right? Yes, so we'll record according to what we have seen. Okay, so we'll say the color of blue litmus paper remains the same after dipping it in solution A. Okay, so with practical, never go with answers in your head. Okay, you write what you observe while doing the practicals or the experiment. Okay, so as we have seen that the color has remained the same. Okay, then we go to another part, okay, which is the part 2 says put little amount of solution B to a test tube and dip red and blue litmus papers and make observation. Okay, so we'll pick um, solution B, and then we'll get a different test tube because there were three. Okay, then we'll get a dropper, a clean dropper again. Then we'll pick few drops of solution B and then put them in a test tube. Okay, then after we do that, we'll also get a red litmus paper and dip it there and make observation. So our observation here, we have seen that nothing has happened, right? So we'll say the color of red litmus paper remains the same after dipping it in a solution B. Okay, then we'll also dip blue litmus paper. Okay, so we'll get our blue litmus paper and also dip it and observe what happens. Okay, so we see that the blue litmus paper has changed to red. Okay, so our observation 2 says we'll write it as the color of blue litmus paper changes to red after dipping it in solution B. Okay, so that's what we have seen. Okay, then we go to another part of the experiment, which is the part 3. Procedure 3 says put little amount of solution C to a test tube and dip red and blue litmus papers and make observations. Okay, we'll get here solution C and then also a different test tube and a clean dropper again. Get few drops of solution C and put them into the test tube, and after that we'll also pick a red litmus paper and dip it there and also make observation. Okay, so what we have seen is what we're going to see. So we haven't seen any change. So same observation 1, the color of red litmus paper remains the same after dipping it in solution C. Okay, so that's what we'll do. The next we'll dip what? Blue litmus paper. Okay, so get blue litmus paper and dip it there as well and also make observation. So we'll write observation 2, the color of blue litmus paper remains the same after dipping it in solution C. Yeah, it has remained the same after dipping it in solution C. Okay, so we write what we see. Okay, then next we go to part B of the practical. Okay, you may have so many parts, but this one has got part A and part B. So part B says using the universal indicator solution provided and the pH chart, determining the pH values of solutions A, B, and C. Okay, so here we are going to use a universal indicator that has been provided and then pH chart to determine the pH values of solutions A, B, and C. Okay, so here we have one solution A here, and then we'll pick first solution A, and here we have the universal indicator and the test tube. Okay, so procedure 1 says put little amount of solution A to a test tube and add a few drops of universal indicator and make observations. So what we are going to do here, we are told to put solution A to a test tube. Okay, put little amount of solution A to a test tube. So we'll use a dropper, then pick solution A and then put it to a test tube there. Okay, to a test tube. Okay, put it to the test tube. Okay, then what we are going to do next is to get the universal indicator, because it says add few drops of universal indicator and make observation. So this is the universal indicator, so get few drops of the universal indicator and add and make observation. Okay, so you see, as we add, what we have seen is color change. Okay, so what color have we seen here? We don't know the color. If you don't know the color, you may be given the pH chart which contains colors. Okay, so pick the pH chart with colors and then compare the color. So this color is similar to violet here, so make observation. Or say solution A changed to violet after universal indicator solution was added to it. Okay, yeah, that's what we have seen. Okay, then again, part 2 of part B says put little amount of solution B to a test tube and add few drops of universal indicator and make observations. So we'll pick again solution B. Again, we'll get few drops of solution B and also add to the test tube. And then what we do, we pick universal indicator and also put the drops there, make observation. Okay, so what we have seen is color change. So again, we'll get the pH chart and compare the colors. Okay, so the color we have seen is red. Okay, so this matches with the red. So our observation will say solution B changed to red after a universal indicator solution was added to it. Okay, then you also go to another part. Part 3 of part B says put little amount of solution C to a test tube and add a few drops of universal indicator and make observations. Okay, so we'll get it. This is the solution C. Okay, so this is the solution C. We'll get few drops of solution C there. Okay, and add them to the test tube. And after that, then we'll get the universal indicator here. Okay, universal indicator. Then we'll add also drops and make observation. Okay, so what you have seen also color change. Okay, so if you don't know what color this one is, as usual, you get the universal indicator and compare. So this one is comparable to green. So we'll make our observation as solution C changed to green after universal indicator solution was added to it. Okay, then after that you may have questions like that. So like question 1 says, from the results obtained in part A of the experiment, what is the identity of the unknown solutions A, B, and C? Okay, so now after doing the practicals, we have recorded our observations. Now we want to use those observations to answer these questions. Okay, because now they are saying you from the results obtained in part A of the experiment, what is the identity of the unknown solution A, B, and D, C? Okay, so we want now the identity. Okay, so we want the identity. So now what we are going to do is to go back to the results that we got first for A. Okay, so we'll come to A where we did the observation. So for A here, the observation was that the color of red litmus paper changes to blue after dipping it in solution A. So it changed to from red to blue after dipping it in solution A. So on the topic of acid, bases, and salts, so one of the characteristics of acids is that it changes a blue litmus paper to red, and one of the characteristics of bases is that bases changes a red litmus paper to blue. So now since we have seen a red litmus paper changing to blue, then which means that solution A is a base. So we are going to go back to our question here and record our answer as solution A is a base since it changed red litmus paper to blue. Okay, so then again now we'll go to B. We'll get back to the results that we got for B. So come to B here. So we saw that the color of red litmus paper remains the same after dipping it in solution A. So this one will not help us. This part 2 here says the color of blue litmus paper changes to red after dipping it in a solution B. So meaning that when we dipped a blue litmus paper in solution B here, a blue litmus paper changed to red. Again, what changes a blue litmus paper to red is an acid, because acids are said to be substances that changes blue litmus paper to red. Okay, so meaning solution B is an acid. So we'll come here and record solution B is an acid since it changed blue litmus paper to red. Okay, then we'll go back to the results we obtained for C. So here C, we saw that here observation 1 here is that the color of red litmus paper remains the same after dipping it in solution C. So it remains the same. So this one will not help us. Again, this one says the color of blue litmus paper remains the same after dipping it in solution C. So meaning both red litmus paper and blue litmus paper were not affected by solution C. So meaning this solution C is neutral or water, because only water has no effect on blue and red litmus paper. So we'll get back to our question and we say solution C is a neutral solution or water, since it did not have an effect on both the blue litmus paper and the red litmus paper. Okay, so another question you might have is question 2, which says from the results obtained in part B of the experiment, what is the pH of each of the unknown solutions A, B, and C? So those that part B of the practical that we just demonstrated. We are asked to identify now or to state the pH of solution A, B, and C. So we'll get back to part B and then we'll look at first A. So this is part A. So for A here, when we added universal indicator, what we saw color change, okay? Then we said solution A changed to violet, okay, after a universal indicator solution was added to it. Now, this question here is asking us to do what? To state the pH. What is the pH of each of the unknown solutions A, B, and C? So they want specifically pH here. So what do we use to find pH? So we use the pH chart. Okay. So this color, which did change to violet, corresponds to a certain number here, which is the pH. So these are pH values from 1 up to 14 on our pH we are using here, but usually they will range from 0 up to 14. Okay, so now this violet here has a pH of 13. Okay, so we'll get back to our results and then say the pH value of solution A is 13. Okay, now we move to B. So we'll go back to the results for B on part B also. So here we see that the solution B changed to red after universal indicator solution was added. So we'll go back and see the red, what pH value does it have? 1. So we'll get back and say the pH value of solution B is 1. Again, we'll go back to the results for solution C in part B. So this is part B, solution C. We saw that solution C changed to green after universal indicator solution was added to it. Okay, so green. So we'll get the pH and get this green here. Its pH value is 7, and we come back and then we'll say the pH value of solution C is 7 here. Okay, then you may have another question like this one, question 3, which says using answers to question 2 above, then A, state whether solution A is a strong or weak base. Okay, so now those answers that we have gotten there, we have seen that A has a pH of 13. Okay, so they want us to state whether, since we said it is a base, okay, then they want us to state whether it is a strong or weak base. Okay, so here you must know that the higher the number, the stronger the base, and the lower the number, the weak the base. For instance, above pH of 7, we have bases. Okay, so 8, 9, 10, 11, 12, 13, 14, these are bases. But the bigger the number, the stronger the base. Okay, so since 13 has gotten A has 13, meaning solution A is a strong base. So we are going to say solution A is a strong base because the higher the pH value, the stronger the base. Okay. Then B here says state whether solution B is a strong or weak acid. Again, from the results that we obtained, we saw that the solution B is an acid. Okay, now they want us to state whether it is a strong or weak acid. Okay, again, going down from 7, like 6, 5, 4, 3, 2, 1, 0. So these numbers, they indicate acids. Therefore, acids. Again, the smaller the number, the stronger the acid. And solution B had the pH value of 1. So meaning it's a strong acid. Okay, so we are going to say solution B is a strong acid because the lower the pH value, the stronger the acid. Okay, then we have another question. You can have another question like this, which can say, state the type of reaction which occurs when solution A is reacted with solution B and also state the products formed. Okay, these are typical questions which may come on such a practical. So they are saying, state the type of reaction which occurs when solution A is reacted with solution B. Okay, when this solution A is reacted with this solution B, you state the type of reaction which occurs and also state the products formed. What products are also formed? Okay, so you must understand that this one we said is a base, this one is an acid. So you must remember that when we looked at the topic of acid and bases, we said acid and bases react in a neutralization reaction to form salt and water only. So a reaction between A and B, between a base and an acid, is a neutralization reaction and the product formed are salt and water only. So we are going to say the type of reaction which occurs between A and B is a neutralization reaction and the products formed are salt and water only. Okay. And you may have also a question like this one here, which says, if a farmer discovered that the soil type of his farm had a pH value of 4, yet the oranges he wanted to grow in his farm requires a pH value of 6 to 7, suggest what the farmer should do to bring the pH value, the pH of the soil to 6 to 7 range. Okay, 6 to 7 range. Okay, so here is now an application of acid bases and salt now knowledge in real life. So they are giving you a scenario where they're saying there's a farmer that has discovered that the soil type of his farm has a pH value of 4, but he wants to grow oranges in that farm, but these oranges requires a pH value of 6 to 7. So they're asking you to suggest what the farmer should do to bring the pH value of the soil to somewhere 6 to 7 range so that he can be able to grow oranges there. Okay, so let's push this one up here. Okay, so here what you should know is that we talked about the importance of acid-base reaction. If you remember in that lesson, all those who are in the lessons that I'm doing online can remember these. Okay, so if you are not yet, you can now join on the number appearing on the screen, or you can also uh, uh, click on the WhatsApp button below there, and then you contact me to join for online lessons. Okay, so now what the farmer should do here, we are saying the farmer should neutralize the acidic soil, okay, by either adding crushed calcium carbonate, which is also known as the limestone, or calcium oxide, also known as the quicklime, or calcium hydroxide, also known as the slaked lime. Okay, so when the farmer adds these to the soil which is acidic, because this soil which has a pH value of 4, it's actually acidic, so it can only be neutralized by actually treating it with calcium carbonate, which is limestone, or calcium oxide, which is actually a base which can neutralize the acid, which is the calcium oxide, or actually calcium hydroxide as well, which is a base, so that it neutralizes and it brings the soil pH to somewhere 6 to 7, so that he can be, or she can be, able to grow the oranges in that farm. Okay, so guys, this is the end of our chemistry practical lessons on acid, bases, and the salts. If you have enjoyed the lesson, please give it a like, and also follow the page, and also let me know in the comment section. Okay, as for now, bye and see you in the next lesson. Peace.